All right, this is the somewhat last topic for chapter 7. We may or may not do 7.4. We'll see how the semester goes. But for 7.5, we have Systems of Inequalities. So the second half of this chapter, because it's equations and inequalities, okay? This will be a nice, easy one compared to 7.3. It's a little bit of review. So some steps here in the beginning, how to graph inequalities. We sketch the graphs, okay, of the equations. Pretend there's an equal sign. Use the slope, the intercept, zeros, whatever we know about the equation. And then we're going to use dashed lines if it's less than or greater than, solid lines if it's less than or equal to, or greater than or equal to. Okay, so just some review. The second step is to test a point from each of the regions to see where the shading is going to actually happen. Okay, so these are just some quick, again, steps on how I'm reminding us how to graph these inequalities. Well, I hope my pen's not dying here. All right, so let's look at an example. We have y is greater than or equal to x squared minus 9. So we're starting with a quadratic here. A couple things before I start. Well, I guess I can draw the graph. It's no big deal. Let's draw a little xy axis here. So 1, 2, 3, 4, 5. I'm just going to do 5 on each side. 1, 2, 3, 4, 5. For these, I'm probably going to do these smaller because I see there's a minus 9. So I'm going to have to go down to 10 probably here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, that looks good enough to me. If this were an equation, okay, I'm going to pretend it's an equation. I know from here that the y-intercept is 0, negative 9. Okay, so there's that point right there. I also know that I can factor this one into x minus 3 and x plus 3, which would give me the zeros. Okay, x equals, in other words, if I set this equal to 0, okay, so x equals 3 and x equals negative 3. So let's plot those guys also. 2, 3. And that's a pretty decent sketch of what this is going to look like. Okay. I also know that this part right here is telling me that this is going to be a solid line. So this is going to be solid, which means I can go ahead and connect this like so. Something like that. Okay. All right, so from there, we're going to go ahead and do the step number 2, which is to test a point from each region. So here's how you kind of do this part. We want to label the regions. We have this region on the inside. Let's call this region 1. And then we have this region here on the outside. Let's call this region 2. So we're going to get some test points from each of these regions. From region 1, I'm going to use the easiest one, 0, 0. So I'm going to use 0, 0, and I'm just going to plug that into my equation here. So y greater than or equal to x squared minus 9. So 0 greater than or equal to 0 squared minus 9. And let's see if this is a true statement. So 0 is greater than or equal to 0 squared is just 0, so I have minus 9. This is in fact true. So it looks like my region 1 is going to be my answer, but let's say it wasn't. We have to check the second one. So for the second region, I have to choose anything that's out here, okay? So I'm going to use 0, negative 10, because why not? I mean, it has 0 in it, so why, might as well, right? And we're going to plug in that one now into our equation. So a little bit more clear. There we go. So 0, negative 10. Okay, same thing. So that's going to be negative 10 greater than or equal to 0 squared minus 9, which is negative 10 greater than or equal to negative 9, which is a false statement. So it looks like region 1 is where we are shading. Okay, so I would just shade everything in here. And you can see that this is unbounded here at the top, which means that there's no like restriction here at the top that's going to force it to be just this region. It's going to be everything up above this parabola. Okay, and that's basically it, guys. Let's try another one. Something super quick. Something's not that easy, but still somewhat, not that difficult either. So here we have having some camera issues here. Here we have x plus 2 squared plus y minus 2 squared less than 16. This is something that you probably, I don't know if you remember or not, but it's actually a circle. Okay, this is a circle where our center, okay, is at HK. Move that over. And the radius is the square root of whatever this guy is. So I'm just going to put square root of r squared. So in this case, my center would be -2. So -2 from here and +2 from there. Remember that since it's going to be the format of this equation is x minus h, y minus k. So it's kind of like the opposite of whatever you have here. Okay. And our radius, our r, is going to be the square root of 16, which is just 4. Okay, so let's go ahead and do a quick little sketch of this. Okay, I'm going to go ahead and put my points. -2, let's see, 1, 2, 3, 4, 5, 6, 7, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just going 10 up and down. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 6, 7, 8. All right. So the center's at -2, 2. So -2 and then 2. So about right here. And the radius is 4, which means I'm going to go 4 this way, left, down, and up. So from here, 1, 2, 3, 4 over here at 2, 2. I'm going to go up 4. So 1, 2, 3, 4. So here at -2, 6. 4 across, so same deal, 1, 2, 3, 4, which would be -6, 2, and then 4 down. So 1, 2, 3, 4, which is going to be -2, 2. So, mine doesn't look like a great circle, but that has to do with the way I spaced out my points. If you notice my y-axis, I made those closer and this one not. But either way, it's supposed to be a circle. Okay, so let's pretend it's a circle. This one is saying less than up here. So that means that this should be dashed. Okay, so I know I kind of just did this over. I'm going to put the dashed part like this. And then just like the one before, we're going to find some test points to see where are we shading. Are we shading inside this circle? So let's call this our region 1. Or are we shading outside of the circle, or region 2? Okay, so for region 1, we're going to use the easiest point, 0, 0, because 0, 0 happens to be inside region 1. There it is. Okay, and we're going to plug that into the equation. So it would be 0 plus 2 squared plus 0 minus 2 squared less than 16. That's going to be 2. 2 squared is 4. Again, that's also going to be -2. -2 squared is also 4. And this is saying 4 plus 4 is less than 16, which is just 8 less than 16. So that one looks like it's okay. So it's probably going to be region 1. But let's check region 2 anyway, just because. But for region 2, I want to use something that's, somewhat kind of easy also. Let's do, let me see. Let's do maybe 3. 1, 2, I'll use this point over here. 1, 2, 3, 0. I'm going to use 3, 0. So just like the one before, we're going to plug all that in. So I'm going to have 3 plus 2 squared plus 0 minus 2 squared is less than 16. Okay, 3 plus 2 is going to give us 5. -2 is just going to be -2, right? 5 squared is 25 plus 4. And you can already see 25 plus 4 is going to be way bigger than 16, so this one's not going to work. So it looks like region 1 is our area. where we are shading. Okay, and that's it. That's it for this example. Okay, so let's go ahead and move on to another one. We have 3 examples on this one that are kind of easy. I'm going to go a little bit fast on this. We're just sketching these really simple inequalities in case you get something like this and you don't know what to do. Okay, so you can see that this first one, x is less than 4, there's no y at all. Okay, so all we're going to do is look at where the x is. So let's find 4. 1, 2, 3, 4. I know from here that this is going to be a dashed line at 4. And since there is no y-intercept, there's no slope, this is actually a vertical line, like so. Okay, and when you deal with the vertical lines, it's a little bit easier to see because all you have to do is say, well, x is less than 4. So anything less than 4 is going to be everything to the left. So it's everything over here. Okay, all this. Hopefully you color nicer than I do. And that's it. Easy as that. Letter B, another graph. Now we're looking at our y. Okay, y is greater than or equal to, so that means it's going to be solid, at -2. So 1, 2, 3, 4. Just put it down here. So there's -2. This one has no, let's see, it doesn't have a slope. The slope is 0, right? So that means that this one would be across, like so. So I'm just going to put a solid line, pretend that went through -2, like so. And it's greater than or equal to -2. So it means it's everything above -2. So in this case, you're shading everything above that -2. And I hope this is, like I said, this is Algebra 1 material, guys. If you don't remember this, that's why we're going over it. Hopefully you do. If you have any questions, always let me know. Okay. Yeah, that's basically it for these two. Let's look at the last example on this page. X minus y is less than 1. Okay, so this is a linear inequality. Okay, the one we did before was a quadratic, and then we saw a circle. This one's going to be a line, so you want to think of it like y equals mx plus b. Okay, so we're going to put that in that format. So to do that, we would move the x, right? So we have negative y is less than negative x plus 1. And then we have this negative, so we have to divide everything by -1. But there is this little tiny thing that we have to remember whenever inequality symbols are involved. Okay, if we're dividing by a negative, you have to flip it. So y is going to be greater than x minus 1, and this is what we're going to use for reference to do our graph. Okay, here our slope is just 1 because there's an imaginary 1 there, and our y-intercept is going to be -1. So with that in mind, let's draw the graph real quickly. Let's just do a few. 1, 2, 3, 1, 2, 3, 4, 5. Let's do 5. 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. If you have graph paper, that would be so much better. Just saying. I don't, so I'm making do with what I got. So our y-intercept is -1, which means I'm going to start right here in the middle. Well, not the middle, but here at -1. And I also know that from here, this is going to be a dashed line. So make sure whenever we do our next point, we're doing dashed, okay? The slope is 1, which means from here, you're going to go up 1, over 1, up 1, over 1, down 1, over 1, and so forth. So it looks like this one does something like this, okay? And it's kind of obvious which one we're going to shade because it tells us right here. But let's go ahead and do our test points just to be sure. So we have region 1, which is everything up here, and region 2, which is everything down here. We are going to use our original function to do the test points, okay? So let's go ahead and pick some points. Let's pick for region 1, the easy one, 0, 0, because it just happens to be there. So for region 1, we're going to plug into x minus y is less than 1, which would give us 0 minus 0 less than 1. 0 minus 0 is just 0. So 0 is less than 1. Yep, 0 is less than 1. So it's probably going to be region 1. But let's just make sure. So region 2, let's use 2, 0, this point right here. All right, so it looks like region 1 is going to be our answer. And if we compare it to what we got over here, where y is greater than all of this, greater than means everything above, right? So it is everything above. So we can see that even though we did flip the sign here, everything still came out okay. Okay, so that's it for this one. Moving on. All right, so now we have more than one inequality. This is called a system of inequalities. So what we're going to do is we're going to graph them. And then I do have a note up here that says to be more precise, we can find the vertices of this region, so kind of like the corners, if we were to solve the systems in pairs. Okay, so we may or may not do that. We'll see if we have time for that. We're going to start by rewriting some of these. So it looks like all of these are linear. Okay, so that means this one I can rewrite it like the following. Y is greater than or equal to negative x plus 1. So I just move the x over. And this gives us our slope of negative 1 and our y-intercept of 1. Okay, this one I can rewrite as, let me see, positive x plus 1, because again, this guy comes over and becomes positive. So now I have m is equal to 1 and b is also equal to 1. Okay, and the last one is just, it's like the letter B we saw in example 3, so we don't really have to do anything to that one. If you wanted to, though, you could say that the slope is 0 and the y-intercept is 2 because, well, it's just 2. Okay, so we can put that in parentheses if you want. So let's go ahead and graph this and see what this looks like. Okay, I'm going to go ahead and do, I'll do about 7. 1, 2, 3, 4, 5, 6, 7. 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 4, 5, 6, 7. All right. And I'm going to plot each of the lines. Okay, I guess I can color code this part if you'd like, just to make it a little bit more colorful. So let's do our first one here. I'm going to do it in this color blue. We're going to start at 1. So there's 1. And the slope is negative 1, which means I'm going to go down 1, over 1, down 1, over 1, down 1, over 1, down 1, over 1, and so forth. And for these, you kind of want to do a few because you want to make sure that you have the general idea of where they would land. Okay, so it's something like that. Okay, and according to this is going to be a solid line. So I'm going to go ahead and connect this line like so. If you have a straight edge or a ruler, that would be great. Okay, so there's that first line. For the second one, I'll use purple, I guess. They look kind of similar, but that's okay. So this one is well, actually let's use pink because that's like really different. Or it's not different at all. Let's use that color. So for this one, again, I'm starting at 1. So that point is still here, but that slope is going to be positive 1. So up 1, over 1, up 1, over 1, and then the opposite on the other side. And this one is also going to be solid because of that line right there. So it looks like this one's going to be something like this. Oh, I didn't mean to put the arrows, but that's okay. Hopefully yours is straighter than mine. And then the last one is going to be that y is less than or equal to 2. So let me see if I can get a different color. Let me try this one. There we go. So this one is going to be also a solid line because of the little line underneath the inequality. Okay, and we're going to go to 2 for this one. So here's my y-axis. I'm going to find 2. So there it is. And I'm just going to put a line straight across. Okay, and now what we need to do is we need to figure out which region all of these are in. So we can do it by the symbols. I'm going to go ahead and do test points just because I do want us to get into the habit of that. We have quite a few regions. Okay, we have region 1, which is everything up here. So let's just pick our points as we go. let's use this one. See, 1, 2, 3, 4, 5. So 0, 5 will be for region 1. Okay. Region 2 is this space right here. Okay. So let's see, 1, 2, 3, 3. We can use, well, no, it's not, maybe not that one. 4. Well, you want to make sure it's in the area. Okay. Let's use 4, 3. So 1, 2, 3, 4. 1, 2, 3. So somewhere here. So I'm going to use 4, 3 for region 2. This area right here is going to be region 3. Let's use an easy one. 2, 0. This will be region 4. So let's use the nice and easy one, 0, 0. Region 5 will be over here. So let's use another easy one. Let's do 1, 2, 3, 4, negative 4, 0. Okay. Region 6 is going to be this piece right here. So let's use negative 4, 3, just like the one over here, but negative. And last but not least, we have the region right here in the middle. So this one's going to have to be kind of a decimal because you see that it's between these, okay? So let's use 0, let's see, 0, 1.5. This will be region 7. I'll put the point over here right now, okay? So let's test all our points. Let's do that down here. Test points. Now the thing with these is that it does have to fit, it has to be true for all 3. Okay, so that's where the work kind of comes into, gets a little bit annoying, I guess, after a while. So for region 1, we are going to be using 0, 5. I'm going to put it right here, 0, 5. So for the first equation, we have, let me see that so I can see what it is. We're going to have x plus y greater than or equal to 1. And I'm going to do these kind of quick, okay? So 0 plus 5 greater than or equal to 1, that's going to be a check because 5 is greater than or equal to 1. For the second equation, we have negative x plus y is greater than or equal to 1. So again, we're going to have negative 0 plus 5 is greater than or equal to 1, which is also going to be a check. And then we also have the last one, which is y is less than or equal to 2. So we have 5 is less than or equal to 2, which is not true, which means that region 1 is not the answer. Okay, let's try region 2. Region 2, we went ahead and chose the point 4, 3. So I'm going to just use these same equations. Okay, so we're going to have 3 plus 4 is greater than or equal to 1, which is 7. So that one looks good. Then we're going to have negative 3 plus 4 is greater than or equal to 1, which is going to be 1 greater than or equal to 1. So that one is also good. Okay. And then we have y is less than or equal to 2. So 3 is less than or equal to 2, which is not true. So 2 is also out. Okay. Let's try 3. In our section 3, we chose the ordered pair 2, 0. So that's going to be 0 plus 2 is greater than or equal to 1, which is true. Then we have negative 0 plus 2 is greater than or equal to 1, which is also true. And then we have 0 is less than or equal to, I'm sorry, not 0. 2 is less than or equal to 2, which is also true. All right, so that would mean that this is the answer, right? Let me go back and check one more time to make sure, because if you have this many regions, you do want to double check. So this first one, we have 0 plus 2. Okay, that one's okay. This one, negative, oh, hold on. Maybe not so much. Negative x, so this should actually be negative 2 plus 0, which is negative 2, which is not true. Okay, so there we go. My bad. Nope, not going to work. So let's try section 4. Section 4, we have the nice and easy one, 0, 0, which would just be 0 plus 0 is greater than or equal to 1. 0 is not greater than or equal to 1. So right away, if one of them is wrong, you can stop and you can move on to the next one. Okay, so checking region 5, which is negative 4, 0. Okay, I'm almost out of space. That's why I'm writing smaller and smaller. So we're going to have, let me go a little bit slower so I don't mess up. -4 plus 0 greater than or equal to 1, which is -4 greater than or equal to 1, which is not true. So again, we can stop at this point. Let's try region 6, which we chose -4, 3. Okay, so we're going to have -4 plus 3 greater than or equal to 1, which is -1 greater than or equal to 1, which again is not true. So we better hope it's region 7, otherwise we have to go back and check. Region 7, I think I said 0 and then 0.5 because it's kind of in the middle, or 1.5, I'm sorry, 1.5. So let's check. We're going to have 1.5 plus 0 greater than or equal to 1, which is true. Okay. Then we have -1.5 plus 0, which is greater than or equal to 1, which is not true. Oh no, where did we mess up? Let me see. Give me one. Let me check real quick. All right, so it looks like it's just me going too fast. -x plus y. This is what we're supposed to be using, right? So this is what happens. I'm doing this on purpose to show you what not to do. Over here, it didn't matter because x and y are both positive, so really it was 0 plus 1.5, which is still 1.5, okay? So here we want to put -x, which would actually be -0 plus 1.5 greater than or equal to 1, which still comes out. If I lost you, just let me know in class and I can go over this slower. Try not to make the video too long, okay? And then of course the last one, let me write it down so I don't mess up. Y is less than or equal to 2, so it'd be 1.5 is less than or equal to 2, which is in fact correct, which means after all that work and those two mistakes, region 7 is the answer. So over here, I'm going to go ahead and shade in that little tiny triangle. And it usually is the little triangle that's formed when you have 3 inequalities, but we want to make sure. Okay, so let's go ahead and move on from that chaos here. Look, we're almost done. We have one more to go over, and then the last two I'm actually just going to show you because I don't want to waste too much time. So for example 5, we are going to graph a quadratic and well, not really a quadratic, it's actually going to be a square root, but something squared and something linear. So we have to solve both of these, okay? So let's go ahead and do that first. We're going to pretend that they're equations, and we're going to solve. So this would be -y squared is equal to -x. You can get rid of the negatives by dividing by -1. So y squared equals x. Take the square root. So y is equal to plus or minus square root of x. Okay, which actually means there's two pieces to this one. Okay, well, the other one, x plus y equal to 2, is going to give us y equals -x plus 2. Okay, so from this one, we can see that our slope is -1 and our b is 2. For this one, if you don't remember the values of square root of x, you might want to make a little table just really quickly. We can do y equals square root of x, and then another one for y equals negative square root of x. Just so we have some values here, okay? These start at 0, so 0, 0. You put in a 1, you still get 1. I'm going to jump up to 4 because the square root of 4 is 2, and then the square root of 9 is 3. These are going to be basically the same, but since you have a negative in the front, basically the function just flips over. It flips over the x-axis, so this would be 0, 0, 1, -1, 4, -2, 9, -3. Okay, there's just some points that we have for reference. So let's go ahead and draw this graph. Okay, let's put it right here. And I'm going to go ahead and do 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on this. I'm not going to worry about this because, well, I guess I can put a few. 1, 2, 3, 4. But you'll see why in just a bit. Let's graph these ones first. So 0, 0, 1, 1, and then 4, 2, 1, 2, 3, 4, 2. So I know this is going to be something like that. And I'm putting a dashed line because way from the top beginning, both of these are dashed. Okay, and I have the second piece, the other half of this on the other side. So 1, -1, 4, -2, and it looks something like that. So it's kind of like a sideways parabola. It's a little bit special because this isn't actually, if you were to do this as a 1, it wouldn't be a function, which is why we have to kind of split it up into two pieces like that. Okay. The second one is a little bit easier. It's just a line. So it starts at 2. So 1, 2. Here's my y-intercept. And the slope is -1. So down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. So it looks like this one, we already found the intersection points, something like that. All right. Hopefully you can, let me put this in color a little bit. I know it's kind of hard to see because of the page before. So this one looks kind of like this, the line anyway, so this guy. And then my parabola is the other one. It's the one that, well, it's not really a parabola, but my sideways parabola, I guess you could say, is this one. And it's made up of two different functions, one positive, one negative. All right. So for this one, we're going to go ahead and do it the fast way just because I don't want to spend too much time. Well, actually, let me see. Yeah, let's do this one the fast way. So we've done it with test points. Now I'm going to show you how to do it just using it above and below and all that stuff. So I'm going to take my functions again down here, x minus y squared greater than 0, and then x plus y less than 2. And I'm going to solve for y. Okay, so this one again is going to give me, based on what I had on the top up here. Okay, well, we can do it step by step. So it'd be negative y squared greater than negative x, divide by -1 because that's to get rid of the negative, okay, which would be y squared is less than x, meaning we have to switch the sign because of this negative that just happened. And then we take the square root, so y is less than the square root of x. And we're just going to take the positive one here because it would be tricky otherwise, okay? For this one, we go ahead and just move the x, so it's y is less than negative x plus 2. Okay, so you want a point that's below the square root of x, and then you want a point that's below negative x plus 2. So if I look at my lines, here's my line. Anything below the line is everything that is this way, okay? Anything below my positive square root is going to be this way. So you can see that they intersect right here in the middle. And that is basically it, guys. Okay, so if you did not have easy points like this, where we were able to find the intersection points, no problem. What you would have done, and I know you wouldn't have been happy about it, but what you would have done is you would have done x minus y squared equal to x, let's see, how would we have done this? Actually, no, I'm sorry, not that one. You would have set these two equal to each other. So you would have done square root of x is equal to negative x plus 2 and solve for solutions. So remember that those intersection points are where the two graphs intersect. So what we do is we set them equal to the same variable. In this case, y. They're both equal, not equal to, but they're both, if you put an equal sign, they're equal to y. And then you can set them equal to each other and solve. And you'll see that if you were to do this, you would end up with x equals 1 and x equals 4, okay, which so happen to be the intersection points up here at 1 comma 1, so x equals 1, and 4 comma negative 2, x equals 4. Last but not least, guys, this is just a lot of stuff for you to copy. I just want to go over it real quickly. This is another example, and this one is an example where there's nothing, there's no solution basically. So what happens is we did the same thing we done before. We changed them to linear slope-intercept form, okay? And you can see here that the slopes are the same, but there's different y-intercepts. And when that happens, we know that the lines are parallel. Okay, this means that they are parallel, which means that there's no solution. They don't cross at all. No solution. Sorry, I said that wrong. So when we graphed it, and again, you can take a look at this more in detail when you have some time, but if you graph both lines, you're going to see that according to what we shaded here, okay, this one's above, this one's below. You can see some of the test points that we used here, and you can also see that the shading is correct, but they don't overlap at all, which means that they have nothing in common, and that's why we have that no solution. For this second example, I just went ahead and wanted to clarify what unbounded means because it is one of the terms that you're going to see. I mentioned it in I think the first or second example, but basically unbounded just means that the solution's not restricted in at least one direction. So like this one, without going into too much detail, if you graph it, it kind of looks like this. Okay, you can see that they intersect here, all of the solution set, but it's going to keep going up here. There's no like third line that, stops it from going anywhere else. So this is what it means to be unbounded. Okay. But yeah, that is basically it, guys. If you didn't get that part over here, I'll go ahead and show that so you can get it. These were the test points for the problem before. If you have any questions, let me know.